Hi, I'm Paketa12 and today we'll play with elastic grid, and what I mean by that is this ability of displace grid points in floors. And I did this a while ago, and I realized there are way too many operators, and that's okay. It's called learning curve, I guess. And yeah, you see those onions? Yeah, it's funny. However, we will build this um, much cleaner, and for this tutorial we'll go only for 2D grid, but the process is the same for 3D. So let's grab a grid SOP and take a closer look at the points. Okay, and we'll go for 8 by 8. Okay, let's set a constant here, and we'll say count. It's 8, and we use that parameter for our grid. Okay, and now let's see the points in chops. Okay, obviously we don't need TZ, so we grab only Tx, Ty. So we take Tx and Ty, and let's make this a little bit bigger. Okay, and you see there is some patterns, and we try to recreate these patterns with a noise chop. So noise chop, and here we set Tx and Ty. We have now 2 channels, and the length should be the same as our count in samples. Actually it's -1 here, and now we have 8 points. And this noise will give us values in between, let's see, -0.5 plus 0.5 with the offset on 0. It's like center, and sometimes we'll go above or under, and we don't want that. We always want to have the extreme edges of the grid in the place. So we use limit, and here we normalize, and now we have values in between -1 and 1 with math chop. We can range this into -0.5, 0.5. And now I would like to form those patterns like here above, and for that I select Tx. Okay, and yeah, why I'm using caps, I don't know, I don't like. Okay, so Tx, Ty. Okay, now we select here Tx. Oh, sorry, Tx. Now we good. Also Ty under, and we'll go for the Tx with cycle chop, and we cycle a couple of times after, and actually we use this number here, -1. Okay, and we don't want blend, and 0 here. So we have Tx, and for Ty it's a little bit different approach. We first shuffle and split all the samples, and now we use the same cycle, okay, and shuffle again into one channel. So we use sequence channels by name. Okay, now we use merge, Okay, and let's put a null here. And now we want to change the points in a grid here with these ones, and we use chop to. Okay, and let's put a null in the end, and this is it, right? So we want to see this last one in a geometry viewer. So okay, now let's see wireframe first, and here on chop to we use this chop and say dy goes for p0 p1. Okay, and we got it. However, this method, as it is here now, goes nice only for wire, since we have some overlapping polygons here. So yeah, let's make the noise moving by using ABS time.seconds like this. Okay, now if we play with the count, yeah, we get something like this. And how nice would be if we do this a little bit different in order to get the positions, also the scales for some instances we want to fill the holes, the gaps between the lines. And okay, let's put this aside. So collapse select. Sorry for this noise, it's my neighbor cutting logs, I believe, I don't know. And yeah, let's close this for a second. And if we use noise top, okay, not this one, we need top, so noise top, okay. And the size would be this count by 1, and let's set it back to 8, okay, and 32 mono and nearest pixels. Now these pixels here will represent the scales for our instances, and for this let's imagine how it works on a straight line. We want to have some spheres instance on that line and always have them kissing each other. So how we do that? It's like we need the kind of function, and the input would be scale and the output would be position and scale. And yeah, let's do this. First of all, these values here, if I want to see them, right, so only R, okay, sometimes goes below 0 and above 1, and we would like to clamp that with level, right, and here and here. Okay, now we good. So in the end we'll have this null right here with the data we need. So let's make a folder by using a null and then selected, collapse selected. So this is our function. So I call it f of s6, right? Okay. So we go inside, and first of all we need to have all those scales being 1 when added. So right now they'll might have, I don't know what value. So let's find out. If we use analyze here, we get average, right? And now if we multiply this average with mat, right? And let's split the screen. And from here we'll take this count and use it here. So multiply this average by count will give us the sum here. So let's check what we have now. So yeah. Now if we sum all the pixels, we get to 4.8 and something, right? And we need this to be 1. And we can do this by divide. So we insert the constant, right? Not constant, sorry, composite here. And so we want, let's close this for now. And we want to divide these numbers by this maximum amplitude to get the normalized values. So first let's do this texture the same as the one above. I like that. Either you can do it without and just set the composite to take the input 1 instead. But yeah, it's better for visualizing what actually is done here. So yeah, we'll take the count and we'll use that here. Okay, and now, oh sorry, here has to be only 1, right? Okay, and now let's choose nearest pixels and fit on fill, and here composite, it's divide. Okay, and divide by this texture. Okay, now we have the scales as we want them. Okay, the next step would be to find the positions, right? And I have write the sequence. It's looking like a sequence here. So if my scales are A, B, C, D, and so on, I need to find out the centers for each, and the centers would be on A divided by 2, A plus B divided by 2, and so on, right? And we need to find a rule for all the pixels, and I dare to write this as below here. It's sum of all previous elements plus the element itself divided by 2. And how we do this in Touchdesigner, okay? First of all, let's grab these scales into a fit, and okay, for the fit we go with the same resolution. So okay, and here it's fill, right? And also nearest pixels. Okay, and now imagine if we use analyze here. By finding the average and then multiply with something, we can actually find the sum. Here we go with rows, and we'll have 1 pixel resolution on horizontal, and for each pixel we'll have average for each row, right? but this will give us some duplicates, and we don't want that. So first we only need half of this texture, and to cut it out, that half, I would use a ramp, okay, and go for radial, and here I set the same resolution, okay, and nearest pixel, okay. Now the position is on 0505, and with this on let me see, okay, here should be 5 divided by 8, okay, yeah. And now I use math. Under the line I'll have close to 0, above the line I'll have close to 1. So if now I use round, I'll have a 0, 1 texture, right? And let's multiply this with this one, right? And now I would also like to see the non-pixels, let's say non-pixels, because I will mark with alpha 0 where there's no point to compute, and for that I use reorder. You don't need to do this, but it's good for visualizing. So I'll set this to be black and white mono plus alpha, right? And I'll take the alpha from input to red, right? And now let's set nearest pixels. Okay, let's see now. If we sum on the rows, we have 0 here. Here it's A. Here it's A plus B, and so on. Imagine we already solve this part with sum, right? If we use analyze now. So let's have this analyze, and for having this much cleaner, yeah, I'll put this away. So we don't need this, but yeah, okay. Now analyze, pick the rows, okay, average, I want to see the pixels, and now I multiply this math, okay, and I multiply this by their number, so I have it here, okay, okay, and let's set the nearest pixels, okay. Now we only need to add half of each scale. So how we do this? First let's flip this bottom left, okay, set the nearest pixels, okay, and first divide the numbers by 2, math with math, okay, and we go here, multiply with 1 by 2, and now we add them. So add, okay, and I believe we're done. Here we have the positions, right? And yeah, to to have it in one texture, I would select the input here as I would select the normalize scales, okay, here. So this is scales. Above I have positions, so now I can use reorder, and this has to be RG, okay, and the second input, it's this one, okay, nearest pixels, okay. We're done. This is our function, okay. Now let's see if I'll grab the points out. I have like this, where R it's actually P and green it's scale, right? Okay, now we use a null, sorry, so we use a null here, okay, and let's instance this on I don't know, on some grids. So I use a grid and 2 by 2 here, geometry, okay, instancing on, and I'll take these values here. So now if I put each grid on a position, and then I have, let me split the screen, right? So I have these, okay, and for the scale here I'll say take S, and now I don't know if you see it. Let's make this playing a little bit by ABS time dot seconds divided by 20, right? So now I have instances instead of holes in my grid, so I can see them better if I use a transform here and scale each by 0.95, let's say. Now you see I have this nice kissing instances, and let's use spheres instead. So the only thing you need to do is set the radius by 0.5, since we're taking into considerations the diameter. So 0.5, 0.5, 0.5. Okay. So, being spheres, obviously we need to scale here also by S and by S. So, yeah, this is kissing spheres, and you can have boxes, whatever you want, right? And yeah, we can have some colors here also, but instead I would like to show you how easy you go from one line to a grid now. Okay, so let's close this a little, right? Here I have scales on X axis, and I got in the end positions and scales, and I would like to do the same for Y axis. So let's make a little bit of space here, okay, and let's copy this, And this one would be a different noise, let's say period by now seed by 2. Okay, and yeah, let's build a grid now. Okay, and actually we need to split again these textures, because let me show you. Okay, so I'll take out from here, select, okay, and reorder. Okay, now I have mono here, so this one would be X, so I color red, and another one would be Y, I color green, and I take green here. Okay, and let's see the pixels. Now this one is scales, this one is position on X. I do the same here. Okay, and now I would like to form two textures, one for positions and one for scales. So I make this by using here fit, and the fit will be the same as all the other. So here, right, and I go with fill, and yeah, let's see the pixels. Okay, now the same fit, I use it 4 times, so not this one, sorry. Okay, okay, and out of these two I'll form the texture for position. So reorder, okay, and this has to be 32 RG. Okay, and let's see the pixels. Okay, reorder, the green will be input 2. Okay, and the same for scales. Okay, and yeah, we can take the information out into a chop and have the same approach. However, I'm using the experimental version, so the big advantage here is that I can instance out of either chop or top or dot. So I can have these textures like this. So I name this pos, and this I name it scale. No, just null. Okay, and this is scale. Okay, and what I can do now, let's see, for this geometry I'll use this texture for the position. Okay, so I have R, and position on Y is G, right? And here for scale I'll take the other one, and I use R for scale on X, and G scale on Y. We don't need Z. Okay, so now we delete this, and I believe we good. Let's check a little bit to see what we have here. So Oh, it's something wrong. I know where it is. Okay, so here we have something funny. You know why? Because here we need to flip this. So we flip this bottom left, right? Let's make it like all the others. Clean, okay. And yeah, the same flip goes for scale Y. So, okay. Okay. And now we perfect. And yeah, we can use one of those two textures for color, or we can go, I don't know, let's set the color as they have the scale. So actually as they have the area. So what I want to do now, it's use this scale where I have scale on X and scale on Y, and just have it. So I use select, and now I want to multiply the scale on X with scale on Y to actually find out the area of each um, um, square, each rectangle. So I can do this by using math. Okay. And here I set this to multiply and only take RG. Yeah, I believe it's good. Yeah, it's perfect. Let's set nearest pixels, and here a null. And actually this has to be 32 mono, right? And let's use a noise to have values according with the input. So color 32, yeah. And okay, now I use this texture here for colors. So RGB. Now this is yeah, how you build an elastic grid. We can go quite high with this number here, but you will lose the color, since the color is based on the scale. So maybe it's not a good idea to take values out of the scale. Maybe let's see how we fix this. Okay, so yeah, you get something crazy like this. And there are so many ways of putting the color on those tiles. So many. So yeah, this was my tutorial. I really hope you like it, and yeah, you can subscribe, hit the like button. I also want to let you know you can support me on Patreon if you want to make this more often. I really appreciate it. Thank you. See you in the next one.